Rotation construction. To rotate a figure in angle theta about a point P requires a compass and a protractor. Let theta equal 75 degrees to rotate quadrilateral ABCD 75 degrees counterclockwise. To start, use the compass to sketch 3 circular arcs that pass through the points A, B, C, and D. Be sure to extend the circular arcs into the second quadrant over here to accommodate a rotation of theta equals 75 degrees. Now use the protractor to measure 75-degree angles to map point to point. In the figure below, the protractor is positioned to have point B coincide with 0 on the inner scale here. The point B prime lies on the same circular arc as B at the 75-degree mark on the inner circle, on the inner scale here. So you can see that this is 0 here, B is at 0, and then B prime is at 75 on the inner scale here. And you see that B and B prime lie on the same arc that we drew in the previous step. Now repeat the process to map points on the pre-image to points on the image. In the figure below, the protractor is positioned to have point A coincide with 0 degrees on the inner scale. So A is at 0. See how there's a little 0 here? So we move the protractor to be on this angle here so that A coincides with 0. And then A prime lies on the same circular arc as A at the 75-degree mark on the inner scale. So A prime is at 75. See how this point here is 75 on this same orange arc that we drew in 2 steps ago. See that? In the figure below, the protractor is positioned to have point C coincide with 0 on the inner scale. The point C prime lies on the same circular arc, the orange dashed line, as C did at the 75-degree mark right there. Finally, we have point D. So D coincides with 0 right there. And then D prime is on that same arc, but at the 75. So here's 70, 80. So here's 75. And you can see that D is right at the 75-degree line there. Finally, we connect the dots with pencil and straight edge to complete the construction. So now we have A prime, B prime, C prime, and D prime. So you just use your ruler and draw lines between those points. Here's the final result after connecting the vertices. Its rule is given R sub 75 degrees, comma, P maps x, comma, y onto x, comma, y with a rotation of 75 degrees. Link to interactive graphics. Click the Desmos icon to access an interactive website that demonstrates the mapping of rotations. Here is a pre-image and tools for constructing a transformation. Sketch the image of triangle ABC given by a rotation of 100 degrees around point P maps xy onto xy with a rotation of 100 degrees. The solution is on the next slide. Here is the solution. Here is the image after the rotation. Rotating 90 degree, 180 degree, 270 degree, and congruent triangles. Given the pinwheel figure to the left, there are 4 right triangles where plus or minus a squared plus or minus b squared equals c squared. They share the hypotenuses. Are the 4 triangles congruent? Yes, the hypotenuses of the 4 triangles are radii of a circle, and all radii are congruent. The smallest angles in the 4 triangles are congruent too. The 4 triangles are congruent by angle-side triangle congruence. Rotating 90 degrees in the coordinate plane. Here's an example. We're going to rotate this shape 90 degrees about the origin to map A onto A prime. So A is here, A prime is here. For A equals coordinate 3, 4. All right, so the point itself at A is 3 and comma 4. So that's going to become negative 4 comma 3. The point 3 comma 4 is used as an example. Rotate another point to discover a pattern. This can be generalized for all points P in the plane. When you rotate 90 degrees counterclockwise, so positive 90 degrees, xy becomes negative yx. Rotating 180 degrees in the coordinate plane. All right, in this example, we're going to be rotating this point A 180 degrees counterclockwise, so this way, and a point A that's at 3 comma 4 becomes a point A prime that's at negative 3 comma negative 4. The point 3 comma 4 is used as an example. Rotate another point to discover the pattern. This can be generalized for all points P in the plane. When you rotate 180 degrees, x comma y becomes negative x comma negative y. So if we were then to rotate, say, this point is at 1, 2, 3, comma 0, rotated 180 degrees, and it becomes negative 3, comma 0. So in this case, 0 doesn't really show you how the y coordinate changes, but you can see the x went from 3 to negative 3. So yeah, any point on here will work. Rotating 270 degrees in the coordinate plane. All right, so we're beginning with A here, again, the point 3 comma 4. We're going to rotate 270 degrees counterclockwise, so this way around the circle, and we're going to map out onto A prime. A prime becomes 4 comma negative 3. So a rule for 270 degree rotation is x comma y becomes y comma negative x. Now let's rotate negative theta degrees in the coordinate plane. So now we're going to rotate 270 degrees again, but negative 270 degrees, which means we're going to rotate clockwise. So 270 degrees would land us over here for A prime. So this corresponds to a rotation of negative 70 degrees plus 360, which equals 90 degrees. So rotating negative 270 degrees clockwise is the same thing as rotating 90 degrees counterclockwise. You end up in the same place. So that's what we see here. They're equal. So if you rotate negative 270 degrees clockwise, you get the same result as you get when you rotate 90 degrees counterclockwise, negative 4 comma 3. So you see that these two rules here are the same. X comma y maps onto negative y comma x.